This video addresses factoring special forms of equations. So there are a couple of special factorizations that you've already learned and hopefully that you remember. The first is a square minus a square. We call that the difference of squares. Okay? And we know that must have started out life as x plus 3, x minus 3. There's no other reason that I could have gotten rid of that middle term unless I had opposites here, because when I FOIL that out, the plus 3x and the minus 3x will cancel each other out. So this had to start as a plus minus. Okay? Square root of this one here, square root of this one here, and a plus minus. The other two are perfect square trinomials. So if I started with x plus 3 squared, I must have x squared plus 6x plus 9. The middle term is this times this and doubled. This term is the last number squared, and the first term is the first number squared. Okay? If I had a subtraction in here, then I must have had the same numbers, 3, but it must have been an x minus 3 squared. So it's important that you notice these patterns when you're looking at polynomials that you have to factor, because they'll save you a lot of trial and error. If you can say, hey, wait, that's a perfect square. Let me check and see if this one is 2 times the number. So the perfect square is 3. This is 2 times 3. Okay, I think this is a perfect square, and I will know right off the bat to pull that out as a perfect square. So these are the ones you should already know. Please make sure they're in your notes. Oops, just smeared that one a little bit. These are your new ones. Let me fix this so that it's clearer. Okay. The ones we're going to talk about today are the sum or difference of cubes. Okay. What they look like is this: x cubed plus 8. And of course you would need to know that 8 is 2 cubed. Okay. Another one would be x cubed minus 27. 27 is 3 cubed. So in order to get a sum and difference of cubed, in order to have gotten something that canceled out all of that, we have a little memory device that will help you know that. So we use the device SOAP. SOAP stands for same, opposite, and always positive. Okay, what does that mean? Well, first thing I do is I write the cube of this. So this number cubed and this number cubed. And then the first sign is always the same as here. That's what the same stands for. So if the original problem was a plus, I know that my first number here is a plus. The second one is going to be opposite. So x squared minus 2x plus 4 is going to go over here. It has to be opposite of the original sign. And the last sign is always positive. The last sign will be this number squared. Okay? So far I have x plus 2. Then I take x squared minus 2x. Okay, I take the number and put it with x. And the last term is positive of the number squared. If I did x cubed minus 27, my cube root is x and 3. So I'm going to start with x and 3. And I remember same sign. Same, opposite, always positive. Same goes here. The opposite sign goes here. And the last term is always positive. Okay? So I know this is going to be x squared, opposite sign, same number, 3x, plus the number squared. This is how this came about. So write down SOAP. And know that it goes with sum or difference of cubes. It's a pattern that you need to memorize. What would we do with this? We're doing a simplification. We want to factor this all the way down. So if I'd gotten to here, I could now use the quadratic formula to simplify the next step. Okay? If you don't believe that these actually multiply out, I made a little box here, and I put this term here and this term going this way, and what you'll find is the terms will cancel out all except for the x to the third minus 27. Okay? So if at any time, if something doesn't make sense to you, put it in the box, multiply it out, and double check that it works. Okay, and I've sort of talked about this. We need to bring our polynomials down to simplest form. If we want to find them in factored form, we have to be able to factor that cube down to lower degree terms so that we can solve them. If we look at it and we're stuck and we don't recognize the pattern, then we will have to use a lot of trial and error, which isn't very fun and uses a lot of your time. When are we going to use it? We're going to use it when we have two perfect cubes. So you'll look at a number and you'll think, is that a perfect cube? I have no middle terms, I have nothing else. You could check it on your calculator and see, is it a perfect cube, by taking the cube root. Okay? Let's look at an example of what that is like. X to the third minus 64. Well, I have no middle term, so I think I'm going to check this. It turns out 4 times 4 times 4 equals 64. So I have a cube here of x and a cube here of 4. Okay? So I'm going to use SOAP. Same sign, x minus 4. Then I'm going to go to opposite sign, x squared plus 4x. And the last sign is squared and always positive. This is my new factored form. Now I'm not all the way done. What would I do next if I were truly solving this problem and it said to factor this? This side is good, but this side still needs to be factored. And I don't see any quick way to factor it, so I'm going to solve the rest with the quadratic formula. I came over here and I put in negative b plus or minus the square root of b squared minus 4 times a times c over 2a. Okay? And I'm down, I got 4, negative 4 plus or minus the square root of 16 minus 64 over 2. Now what's important is, please make sure you don't immediately try to take the square root of each of these numbers. I have to take the square root after I've done whatever's in here, adding, subtracting, whatever it says. So let's move it to a new board so we can see what's going on a little bit better. Okay, I've just copied it down up here. Negative 4 plus or minus the square root of 16 minus 64 over 2. 16 minus 64 is negative 48. So I have negative 4 plus or minus the square root of negative 48 over 2. I'm going to pause that and say, that square root of negative 48 needs to be simplified. So I come over here, I pull the negative 1 to the side, and then I just use my factorization. And I discover 4 times 12, and then the 12 is 4 times 3. The 4 comes out as a 2, and the other 4 comes out as a 2, so they equal 4, and I still have that 3 and that negative inside. But I've already learned that that negative sign can come out as an I. So the solution to this little piece right here is 4i over times the square root of 3. And I'm going to replace that with 4i square root of 3. This is how I got it. So now I have negative 4 plus or minus 4i times the square root of 3. Well, looks to me like I have a 2 here, and a 2 here, and a 2 here, so I can call that negative 2 plus or minus 2i times the square root of 3. In other words, just like any fraction, if it's in every one of the terms, I can divide that 2 out. Okay? How would that look once I've actually factored it? Well, remember we had x minus 4 to start with. This one would be called x minus this. So x minus negative 2 is x plus 2, and I chose the plus 2i radical 3. And the other term is x plus 2 minus 2i radical 3. Okay? We're going to work a little bit more with these imaginary numbers and the i's a little later. So I'm not expecting you to be comfortable here yet, but I am expecting you to be comfortable with this level. We can factor it down, we can pull out the I, and we can use the quadratic to get a number. So now, since I expect you to be comfortable, here's a perfect cube trinomial, looks like to me. And please factor that and bring that to class, and we will discuss any issues that you have.